Now we have another topic. 7.2 is all about assessment of health risk, because this all starts from assessment. Once we realize chemicals or biological agents could be really harmful for our employees, for the environment, or even for nearby community, then the best thing is how we gonna assess, especially the health risk. Now, how can a chemical or biological organism enter the body? Which is the highest risk route of entry and why? Over to you, please. This is a very pretty straightforward question. How can a chemical or biological organism enter the body? And which is the highest risk route of entry and why? Over to you, please. Like we have chemicals, how they get enter into our body, what are the ways actually, and what are the highest risk route of entering, and why do you think this is the most highest risk route, over to you, please. How can a chemical or biological organism enter the body? Because we're talking about chemical and biological hazards. Do you think only inhalation or some other methods are also there to support those chemicals to get into our body? What are your take on it, please? How chemicals or biological agents are going to enter the body? Like coronavirus, it goes through nose and mouth. We know this is the route of entry. But what about the other chemicals? Take an example of H2S, take an example of methane gas or some other toxic gases, or any other chemicals even, in liquid shape and solid shape, even in chemical or kind of gas shape. Yes, please. Any one of you want to share your opinion?
Yes, answering your question, the chemicals can affect on the body and to enter the body by inhalation, absorption, also this is by skin,
Mhm.
and ingestion and injection.
Excellent, Michelle. Excellent, Michelle. So, which one is the most highest risk? Because, mashallah, you mentioned all four. Now, the point is, which one is the highest risk group, as per your opinion?
In my opinion, I believe it's the inhalation, since it's not controllable.
Mhm. Okay. Yeah, you're absolutely right. The controls for the gases are like present in the air, especially sometime removing all the toxic fumes from a confined space. Of course, it's required a lot of technical steps to be followed and equipment to be used and a right set of ventilation methods to apply it. Then we can avoid, or maybe the purging process, maybe the water wash and steaming process, maybe plenty of isolation and lockout tagger procedures need to be applied. For what? Just to remove the toxic fumes from the air, because there is more probability of inhalation. Excellent, Marshall. Now, we have routes of entry like inhalation, inhalable dust, all particles could be there. Any process our employees are performing. Take an example of even spray painting, abrasive blasting, or sand blasting, or drilling, or using any vibrating tool, or having some construction or demolition processes or kind of projects, and from anywhere they are getting in shape of dust and more probability of inhalation, right, of smaller particles. Otherwise, ingestion, absorption, like through the skin, injection through the skin, like needle stick, cuts and grazes, bites as well. Now, assessment of health risk, 6 steps are guided by NIBOSH theories. The number one is you have to identify the hazardous substances, like list of chemicals, and I'm sure even as a consultant, I always motivate to the companies to have a master list of everything. Master list of your chemicals, master list of processes, master list of your employees, master list of your kind of processes or machines, master list of your fire extinguishers, even list of your fire first aid boxes available. So the master list basically will give you a magnitude how many areas you truly need to cover in your health and safety system, to manage them. And also the focus area you can easily identify if you have master list. And several companies I noted, they started implementing, the assets management systems, and through accounts and finance in coordination with store manager, along with quality and safety department. So they try to manage all the assets with their code number. Even you take a laptop, you take a chair or table, even right now you can see, what is the asset number of your chair you are sitting if you are in the office. So through that assets control program, they benchmark all the shelf life and the maintenance plans, and everything will be linked to that master list through the assets control programs, actually. Because ultimately it's a money. It's a money, and you don't want to demolish your assets. So you truly need to find a system which can help you to secure and keep safe your assets of company. That is why the assets management program is going to be very much important in the coming days, because of even in the current era, but in coming days it will be more important. I noted several companies, they started managing, the assets control program, and they are implementing. They have specific procedures even how to manage asset. Like if they issue a chair, table, office, and all infrastructure to you, how you have to manage it at your part, and how company will be providing sufficient resources to manage those assets, to keep them safe, not to demolish them over time, because everything have expiry date. So if it is designed for 10 years, at least it should be used for 10 years. Otherwise, it's a loss, right? So the first thing is to identify the hazardous substances. So create a list of hazardous substances, then collect and gather information about the substance. You can get STS, MSTS, or TDS, or some history of supplier and the flammability level and everything, the maximum information you can collect, and the volume you are using within your company operations. Then accordingly, you need to evaluate the health risk and identify any controls needed and implement them. Record the assessment and action taken and review. So 6 steps are guided to assess the health risk, and make sure you don't forget the controls, actually, which are the most important one. Now, how are we going to assess hazardous nature of the substances? Must be in our clear in front of us. Potential ill health effects, and also physical forms, routes of entry, quantity, concentration, number of people, frequency of exposure, duration of exposure, and control measures. These are important factors to consider. Now, product label, as I mentioned earlier, also is part of HAZCOM program, like hazard communication. The system, the chemical, the substance should talk to us by itself, rather than we are asking all information to relevant persons. The set requirements, like name of the substance mixture, hazardous components, risk, phrases like indicating danger, precautions, details of supply. So symbols like this is kind of a danger. That means this chemical, sulfuric acid, is corrosive. It can damage to the metal and also to the human skin as well. Now, there are some guidance document as per NIBOSH, like HSE guidance, note EH40, such UK legal workplace exposure limits. We call it WELS, and maximum concentration of airborne substances. It's also mentioned into that HSE guidance. And there is a EU, like European list of indicative limit values set through 19 different chemical agents, all the legal limits. Otherwise, we can get help from American Conference of Governmental Industrial Hygienists like ACGIH. Threshold limit values, even though these are only the guidelines, but not the legal standards. But still, it's a great source of further learning. Now we have a kind of group exercise. Outline the type of information you would need to know about a domestic weed killer in order to assess the risk. Outline the type of information you would need to know about a domestic weed killer in order to assess the risk. Just let me create one question before we discuss that one. Any one of you have ever studied all 16 sections of any single chemical? Might be you are producing so many different chemicals, but I'm asking only one chemical, any of your chemical, and you have studied all 16 sections of STS or material safety data sheet relevant to that particular chemical. Any one of you, please, all 16 sections of safety data sheet or material safety data sheet. Have you ever studied, even for a single chemical? Any one of you, please. Because this is the foundational document linked to the chemicals, you know. And the good news is for the last, delivering sessions in more than 3,000 companies and having more than 15,000 different students, globally. The drastic part is I couldn't get even a single one. Any student in my safety trainees even who gonna say, yes, sir, we have 100 chemicals and I have studied all the 16 sections of all 100 chemicals, but I'm requesting only one. And I'm telling you, as per my experience, I'm sharing the live reality, the ground reality. We don't bother about it. And sometimes the material safety data sheets are just lying in the offices, not displayed even to that area, like if I'm using the chemical or storing the chemical in the separate storage space. So if I'm going to that area, I need MSDS or safety data sheet to understand that chemical more better rather than directly jump into going near to the chemical and looking at the label only. Label is just giving some key information, but technically in-depth information I can get from safety data sheet. But what I mean is really hard to find a person who study all 16 sections of even a single chemical. But bear in mind, even if a person is not a chemical engineer, but if he studies, like if you have 100 different chemicals and if he study all 100 safety data sheets, to be very honest, you can consider that gentleman as a chemical engineer of your company because he figured all the technicalities, he understood how that chemical, which chemical is more corrosive, which chemical is more explosive or extremely flammable, what properties are there, what first aid measures required, what kind of PPs I need to use, what is the formula of that chemical. If it is touched to our skin, what is the first aid? If it is like touching to our eyes, how we have to act on it. Everything is written in the So 16 different sections of safety data sheet. Same way for the domestic weed killer, we need to know these 16 information like identification of substance and supply. We really want to know who is the manufacturer. Same like Sadara, mashallah, you in your certificate of origin or kind of or even the labeling stickers for your shipments, of course, you're going to mention your name, your contact details, and everything. So, hazard identification of that chemical must also be mentioned, composition of ingredients, and most important thing, the first aid measures, the firefighting measures, accidental release measures, handling and storage, exposure control PPs, physical chemical properties as well, stability and reactivity, toxicological information, ecological disposal considerations, transport information, regulatory information, and other information. And if someone, even is not a chemical engineer, but if he take little bit interest and study all 16 sections of all the chemicals they are using within their company, trust me, you can consider him like a chemical engineer, Marshall, because that is the maximum information you require to handle different chemicals. Now, limitations of information. Information sources provide general information only. Don't consider the specific conditions of use, individual susceptibility, mixed exposures, and based on current knowledge. There are, of course, limitations also because variables are a lot. Like if let's take an example, the terrible monster, the H2S. When we burn H2S, it have a blue flame, first of all. And also the smoke, what we're gonna get, it will create another one like SO2, sulfur dioxide. And when H2S and sulfur dioxide meeting together, they create H2SO4, means sulfuric acid, which is more corrosive, more toxic. So in any way around, those variables are, chemical to chemical would be different. Like if we are mixing different chemicals all together, so it's not the same chemical anymore. We are getting something new actually. So that is why some of the limitations are of course there related to one chemical, especially when that chemical we are using in different other chemicals. The role of hazardous substances monitoring, how are we gonna monitor? Monitoring personal exposure to hazardous substances is sometimes necessary to quantify the concentration of substance that a worker is potentially exposed to. For example, personal dosimeter for dust exposure, a filter and air pump is worn by worker while working, gives average value over time. Same way we use SCABA, self-contained breathing apparatus. We use SABA, like supplied air breathing apparatus. We use respirators, even NIOSH approved, air purification respirator. We use emergency escape kits like EBA, we call it emergency escape breathing apparatus. We also use advanced level breathing apparatus, especially in the mining industry or coal industry. So, or people going into the mostly, multiple workers are working underground. So, of course, we use advanced communication and breathing system actually. Now, the role of hazardous substance monitoring, what is the role? It's kind of a failure or deterioration of control can result in serious health effects. To ensure OEL exposure limits or well, like work exposure limit, or this is occupational exposure limits or workplace exposure limit is not exceeded. To check effectiveness of control measures after any change occurs could affect control. Even after putting the control, still there are some limits. We all know we have to stop the project. We can't send our people again into that danger zone. Even the PPs are there, all control measures you implemented. But if that toxic environment still is going to be out of control and things couldn't be in our favor, then sometimes you stop the project. Even you go and check the history, how many projects were just even geological studies were there, a lot of assessment was done, but still company decided to change the location to go into an area where they would not get uncontrolled possibility of H2S or any other toxic gases. Because it's not like always you're gonna go and explore oil and gas or and start making money. No. You have to think about any segment which can destroy the whole community actually, in case if something goes wrong and at uncontrolled level, then surely you have only one option, because your all studies are gone wrong actually. So now you have only one option to change the location, have another site and avoid that site, and several sites you will be seen closed just because of these reasons. Now, limitations of hazardous substances monitoring is kind of accuracy of results, so variations in personal exposure like habits and practices. Absence of a standard, not everything has a limit, and other exposure routes, monitoring focuses only on airborne contaminants. These are the limitations of monitoring. So plenty of incidents happen, because of no proper gas testing. We have hot work, we have cold work, we have isolation or lockup tag or different processes, but unfortunately, no proper gas monitoring. And the consequences would be horrible for sure. Several incidents, you can go back and check some history. Even you go to OSHA website, you will find plenty of videos. Just how terrible that point is if you don't conduct proper gas testing. And then things would be entirely out of control and we don't get second chance, especially in the areas where the toxic fumes are already there in the air actually.